Now, there are two views of thermodynamic systems. Beyond, control volumes and control systems, there's a bigger view of these things. There's two views of thermosystems. Okay. There's one that is microscopic. Okay. And we're going to look at statistical averages of particles. Okay, we're going to look at these small particles as they're moving in and out of our region. Just say there's a box here that I'm standing in, and there's this little particle. We're going to look at it on that microscopic scale. We need to use this sometime, but primarily this is used by physics and chemistry. You will note that there's no chemical engineering. It's taking this thermo. They take a thermo which is sometimes based upon the microscopic scales, and they have to have a little bit different analysis of it. We're going to deal more with the macroscopic. Okay, we're not going to deal with little individual particles. We're going to deal with regions of particles. Okay, so we're dealing with basically we'll call these the gross effects. Or I'll say regions. Things that can be measured by instruments, thermometers, pressure gauges, those things. This is what we're going to use here. This is our thing that we're going to use in engineering. We don't deal with those individual points. We deal with, hey, a region of space. That's what we're going to be working with. Okay? And we have to define some terms for that region of space in that macroscopic view, and the first is a property. Okay, a property is a macroscopic characteristic of a system to which a numerical value can be given. Okay, at a time, I'll say instead of given, I'll use the word assigned. At a given time, without the previous knowledge, without the knowledge here, without the knowledge of the previous behavior of the system. Okay, a macroscopic characteristic of a system to which a numerical value can be assigned at a given time without knowledge of the previous behavior of a system. Here is probably one of the more important things. You don't need to know how the system got there. You can just give a number to it. Now, what are some properties? Mass. I take the mass of something, I find out it's 3 kilograms. I did not need to know that it was 4 kilograms this morning and we took off a kilogram and moved it someplace else. No, it's a property. I have no idea. I don't have to worry about where it was. The temperature of the room that I'm in right now. It might be 74 degrees in this room, 78 degrees in this room. I don't need to know that this morning it was 71. I don't need to know. I just need to know what it is right now. I can care less about the history of it. That's important when it comes to properties. You don't need to know anything about that history. Okay, so mass, volume, energy, pressure, temperature, those are things. Now there are two types of properties here. Properties are two types. And the first one is an extensive property. And this one depends on the size or the extent of a system. Okay. Maybe think for a second. What would be, of the list I gave you earlier, what would be some properties that are important about the size or the extent of a system? Okay. So my examples here are going to be mass, are going to be volume, are going to be energy. Okay. The bigger the object, probably the bigger the mass, the bigger the volume. Okay, volume depends upon the size very easily. Energy, the bigger the room, the more the energy. The bigger the container, the more the energy that we're dealing with. Extensive properties. Okay. Now the other type of property is an intensive property. Okay, intensive property. And I like to say this is it's independent of size or extent. Okay, it's the opposite of extensive. But my definition is often can be measured at a point. You don't have to add things up. Okay, you can't measure the mass of myself at a point. You got to know about the whole extent. You can't measure the volume at a point. You can't measure the energy of a room at a point. I can, however, measure the temperature at a point. I don't have to add up all the temperatures of this room and say, oh, it's 70 degrees here and 70 degrees here and 70 degrees here. Oh, damn, it's 1,000 degrees inside of here. No, it's at a point. The pressure, you measure it at a point. Okay, you don't have to add up all the pressures here. So those are the two big ones here. Pressure and temperature are intensive properties. Anything we can measure at a point. Okay, that's how I like to look at the definition. The strict definition is it's independent of size or extent. Okay, so I'm going to put here for my examples, temperature and pressure. All right, so this is what a property is. Now, related to a property, no matter if it's an intensive or extensive property, I don't care, we can define the idea of a state. A state is the condition of a system as defined by its properties. Okay, so if we take all the properties of a system, property 1, temperature, property 2, pressure, property 3, mass, property 4, volume, we add all those things up, what we're going to get is the state of our system. That's all under the heading of a state. Okay, now here's a very important idea. You need two properties, I'll say at least, to set the state. And you're going to hear me use the word set the state a lot in this class. Set the state of this system. You need two properties to set the state. It's kind of like looking at an XY graph, you know, X and Y, and you're saying, well, here's property 1, here's property 2. I'm locating it. This is where we are. That's our point right there. I have set the state. I know exactly where we are because I have two coordinates. It's kind of like that in some ways. Okay, two properties to set the state. Now there's some things that works around this, and we'll give you some special cases, but this is the rule of thumb. All right. And after we talk about state, then we have to talk about something called a process. A process is the transformation from one state to the other. Okay. And the key thing is here is that it only needs one property to change for you to change the state, for you to go through a process. So only one property needs to change to undergo a process. Okay. And remember, properties are defined as independent of process. I don't care how they get from state 1 to state 2. I don't care how my temperature goes from 70 degrees to 80 degrees. I don't care. Those properties don't care. But I do know there's a process between those two. My state 1, at time 1, this room was 70 degrees. It had a pressure of 14.7 psi, pounds per square inch. A little bit later, it was 80 degrees, and the pressure rose to 14.8 psi or something like that. Only one thing is needed to change the state, but you could have multiple things, multiple properties to change the state. But it goes through a process. So you have a property. Then you might have another property. Moving between these two properties, you have a property. And all the properties that are related at the moment can give you a state. Okay? That state that you have can go through a process to go to another state. Okay? The going between those two is that process. All right? We'll be using these words a lot. Property, state, process. Property, state, and process. I do want to let you know one thing before we end this lecture segment. It's something about equilibrium. Just talk about equilibrium. There's many types of equilibrium: mechanical equilibrium, thermal equilibrium, phase equilibrium, chemical equilibrium, all sorts of equilibriums. But thermo is all about equilibrium, and equilibrium is where when all changes cease. Okay, we reached equilibrium where everything's balanced out, it's ceased. Now, in real life, that really doesn't happen. So we talk about something called quasi-equilibrium. Okay, and I like to think of quasi-equilibrium as taking a snapshot. Okay, you may have, we'll be looking at things like piston cylinders. Here's my 3D printed piston cylinder here. A piston's going to be moving up and down, like this. It's never really reaching equilibrium. But what we can do is we can take a snapshot right here, snapshot, and look at all the properties there and set the state. And then as this moves, we can take another snapshot, an instantaneous picture of where we are. And we could call those two places at that moment, at that instant, at that nanosecond. They're all in balance, they're all in equilibrium. That's a quasi-equilibrium, although it's going to be moving just like that. Okay? We don't care in thermo about the process so much. We know there's a process that occurs. We care about state 1 and we care about state 2. The process, how things get from state 1 to state 2, that is going to be, that's going to be a class called heat transfer that we're going to be dealing with. Heat transfer is that class. All right. Now, sorry, there's activity going on in the background that you can't see. The other thing you need to know here, and we'll talk about this more, is a thermodynamic cycle. A thermodynamic cycle is a cycle that you begin and end at the same state. Okay. So in my little piston cylinder here, a cycle would be I'm going to start here. I'm going to go up, come back down. Okay, I've gone through one thermodynamic cycle. Begin and end at the same state. We'll talk about all those things. So property, process, state, equilibrium, all these definitions that we go with, we'll be talking about these words in this class this semester.